Moving on to question number 6, here the question says that how many milliequivalents of KCl will be present in 5 milliliter dose of 10% weight by weight KCl elixir. In these type of calculations, I get tempted to start from the end. So 10% weight by weight KCl, that would be the solution, and this is the volume of the solution, and I have to find out how many milliequivalents will be present in that equation. So first of all, just write here the milliequivalent milliequivalent formula. That's milliequivalent is weight in milligrams divided by molecular weight, so and times valency. But because as I said before, that KCl is one of those compounds for which valency is the 1, so for them you don't have to worry about this. Okay, so milliequivalent equation for KCl will remain the same as the millimole equation. So that's one thing. And now start from the end. We have 10% weight by weight volume, which means 10 grams in 100 mils, but I have 5 mils of the solution. So I will find out how much I have, what number of grams or milligrams I have in 5 mils. Because I know that in the equation it would be milligrams required, so I will just convert this into milligrams right here. That's 10 grams, so that will become 10,000 milligrams in 100 mils. So I know from this 10% weight by volume that 100 ml has 10,000 milligrams. So 5 mils will have, because I have to find out in 5 mils, so I have 5 mils will have, now remember I'm trying to find out the milligrams, so I put it on the right side, and it will be this divided by this multiplied by 5. So that means 5 mils, which I have these 5 mils, this 5 mil has 500 milligrams. Now I have from this concentration, so far from this concentration I have worked out how many milligrams will be present in this 5 mils. Now once I know that how many milligrams are present in that 5 mil, I can work out how many millimoles are present by using this equation. So coming back to this equation, we plug the values in. Milliequivalents I have to find out, weight in milligrams I have been, and molecular weight of KCl, which is actually not given here, it's 74.5. Remember, the molecular weight is actually not given. Usually in the questions, in SPLE questions, it will be given, but KCl is very commonly used, so you should know the 74.5 is the molecular weight of KCl. So just calculate this, and it turns out to be 6.71, and we can round it up to 7 milliequivalents. That's the answer. Question number 7, here a 2-month-old full-term baby weighs 5 kg and she has been prescribed augmentin at the dose of 30 milligrams per kg per day, divided every 12 hours orally. What volume of augmentin 125 suspension will be required to dispense each dose? So the concentration of the augmentin suspension is given, and we have to work out the dose for the patient, and then we have to find out how many mils will be required for each dose. So let's start with the dose first. 30 milligrams per kg per day, and it's every 12, divided over 12 hours, divided every 12 hours. So 30, patient weight is 5 kg, so 30 times 5 is 150 milligrams per day, and that has to be divided over 12 hours. So we have to give 150 milligrams every divided over per day, divided every 12 hours. So when you are given a dose which says 150 milligram divided every 12 hours, so that means you have to half that dose if you're trying to find out a single dose. So I have calculated 150 milligram total daily dose, and it has to be divided over 12 hours. So that means each single dose will be 75 milligram, and I will give 75 milligram twice a day. So now I have worked out how many milligrams I have to give for each single dose, and I can convert that into milliliters now from the strength of the suspension. So I know from the strength of the suspension that 125 milligram is present in 5 mils. So 75 milligrams will be present in 3 mils, and so that's the volume of the augmentin suspension I need for each single dose. So that's the answer. 3 mils is the answer. Moving on to question number 8. Here we have to calculate the volume of 10% weight by volume, which is required to prepare 1 liter of sodium chloride solution, which containing 0.2% weight by volume of potassium chloride. So if you again pay attention to this question, we are required to prepare 1 liter of the solution. So this is just the solution, so just ignore this number. So we are required to prepare 1 liter of the solution, which should contain 0.2% potassium chloride, and starting solution is 10% weight by volume of potassium chloride. So it's simply C1 V1 C2 V2 equation again. Our starting solution is 10%. Volume of that we have to find out. Concentration has been given 0.2%, and volume is given as well, is 1 liter. Okay, again, you can see in C1 V1 C2 V2 equation the concentration on both the sides is the same, so it's a fairly straightforward calculation. So that turns out to be 0.02 liters, and if you want to convert that into milliliters, it will be, remember that liter is a bigger unit, so I'm going from a bigger unit to a smaller unit, and the decimal will move towards right by 3 places, so that's 1, 2, 3, and that will become 20 milliliters. So that's the answer. Question number 9 here, the patient has been, we have to give to the patient 400 milligrams ciprofloxacin dose over 1 hour as an IV infusion, and the IV infusion concentration is 2 milligrams. So what rate of infusion we should set? So here we have been given how much dose we have to give to the patient over what time, and we have been given the concentration of the infusion, and we are asked to find out what infusion rate we should set so that the patient gets the required dose in over 1 hour. So let's start with the dose which we have to give to the patient. So we have to give 400 milligrams over 60 minutes, over 1 hour. Now, if you look at the final infusion rate, which I have to work out, is in mils per minute. So it would be much easier if I start converting the units right over here. So 400 milligram will be in 1 hour. That means 400 milligrams in 60 minutes. Right now, in the end, I want mils per minute. So I've got the minutes here. There's 400 milligrams. So the next thing will be how many milliliters are present in this 400 milligrams, and then I can figure out mils per minute. So how many mils are present in this 400 milligrams? I will make use of this information, which is the concentration. So I will use the concentration of the infusion which is given to figure out how many mils are present in 400 milligrams. So let's do that here now. So 2 milligrams present in 1 mil, that's the concentration of the infusion, but I have to give 400 milligrams. So 400 milligrams will be present in how many mils? In 200 mils. So that means I have to give 200 mils in 60 minutes. And in the end, we have to work out mils per minute. So that will be simply 2 mils divided by minutes. So that will give me a number of mils per minute. 3.33, or we can round it up to 4 mils per minute. Okay, moving on to the last question of the diagnostic test, which is about calculating loading dose for drug X in milligrams. given that the doctor wants to obtain the plasma concentration of 2 mcg per liter, volume of distribution is given, and oral bioavailability is given. Now, as I said before, that you need to remember loading dose, which is loading dose target plasma concentration times volume of distribution divided by Solve factor multiplied by bioavailability. So the target plasma concentration which we have to achieve is 2 mcg per liter, 2 mcg per liter, and volume of distribution is already given, so we just plug it in the equation. It's 350 liters. So as I said before, that in loading dose we have to, and also in the maintenance dose equation, we have to write the units for the plasma concentration because that's important. So Solve factor is not given here, so we assume that it is 1, and bioavailability is given, which is 0.7. So here liter will cancel the liter, and we will get the final loading dose in mcg. So that will give me 1000 mcg, and I have to find out the answer in milligrams. So 1000 mcg is simply 1 milligram, and that is the answer.